Okay, so lesson 4 in Unit 2. This is Reflections Part 2. Quick review here. Given the function y equals f of x, replacing x with negative x is actually a reflection in the y-axis. Replacing y with negative y is actually a reflection in the x-axis. So in replacement notation, x goes to negative x, y goes to negative y. If we interchange x and y, that's the inverse function. Here's the replacement notation, and it simply describes a reflection in the y equals x line. So a classic example 1 here is write the equation of the image of y equals x squared after a reflection in the y equals x line. So it's going to be an inverse function. We're going to have to switch x and y's. So here x and y, x goes to y goes to x. So this original function will switch. When we square root both sides, we have to go y equals plus or minus the square root of x. Fair enough. How about this one here, y equals 10 to the exponent x after a reflection in the y-axis. Reflection in the y-axis means x gets replaced with negative x. Here's the replacement terminology. And here's what it becomes. Part C, y equals the square root of x. After a reflection in the x-axis, that means the y's become negative. Y goes to negative y. So this equation will change to y becomes negative y, so this equation here will become negative y equals root x. Bring the negative over, you'll get the following. So you can see that the y values, whatever they were, they've changed sign. All the y values that were positive are now negative, and those that were negative are now positive. Class example 2. Describe how the graph of the second function compares to the graph of the first. How does this compare to this? Let's compare. Well, the x, believe it or not, has not become negative. Otherwise, it would be written y equals negative x cubed. Slightly different. Actually, the y has been replaced with minus y, and then the minus brought over to this side. So here's the replacement terminology. It's actually a reflection in the x-axis. It is saying here that it could also be a reflection in the y-axis simply because it's quite symmetrical, this particular graph. Notice that if you do have negative x cubed, it equals negative x cubed, like this. So actually it's quite a symmetrical function. If you put it in your calculator, you'll see that it doesn't really matter if you reflect in the x or y, you get exactly the same graph. In this one here, we've gone from 2 to the x and 2 to the y. X and y have been switched. So it's a reflection in the y equals x line. Sin x versus sine of negative x. All that's changed here is that x has become negative. It's a reflection in the y-axis. So example 3, graph. The graph drawn in the thick line is a transformation of the graph of the thin line. Write an equation for each graph drawn in the thick line and state whether this graph represents a function. So thin has gone to thick. So what was the original? The original was y equals x squared. What's happened here? It looks like it's the inverse function. So we can switch these. X has become y, y has become x. Square rooting both sides. Y is plus or minus root x. So that would be this new relation right here. Now it's not a function because of the vertical line test. There is actually, for this x value, there's more than one y value. So that's why it's saying it's not a function. So we can't actually use function notation in this particular example. Here the thin line's gone to the thick line. It looks like a reflection in the x-axis, so to do that all the y's must change to negatives. So y has become negative y. So in this case the original function was y equals modulus of x. So negative y equals modulus of x, or can be written with the negative on the other side. This is a function, you can see a vertical line only passes through it once. So we can use function notation. We can say that f negative 1 of x equals negative the absolute value of x. Okay, on to the next page here. It says sketch a graph of f of x, 6 divided by x squared plus 3. So what's that going to look like? We can perhaps do a table of values for that to sketch it. It looks like this. You can also put it in your calculator. Now, if you wanted to sketch this, I would just pick some values of x and plug them in and figure out what this is. So you're just going to have to do a table of values and find out, well, what could this possibly equal? You might want to start with 0, 1, and 2. If this was 0, it would be 6 over 3 or 2. If this was 1, it would be 6 over 4 or it's 1.5. If it was 2, it would be 4 plus 3 is 7. 6 over 7, it's not quite 1. I'm not sure exactly what it would be. You might want to pick a number that would give you, say, 9 plus 3. So that would be 12 on the bottom. So that would have to be x equal to 3. So that's 9 plus 3 is 12. 6 divided by 12 is a half. So 0.5. You can see this is decreasing. What about the other direction? What if we go in negative 1, negative 2, and negative 3? So again, as you can see from the output, it is symmetrical. So you'll get similar values, and it's based symmetry around the y-axis here. So I would suspect here that at negative 1 you'll get 1.5. Negative 2 is kind of hard, but negative 3 squared is 9 again. So that ends up being 0.5. And so on. So you can graph this. Write the equation for y equals negative f of x. Well, here's f of x. We just have to put a negative sign out here, as we do. What's happened here? All the x's have become negative, so this gets replaced with a negative x. But does it really make any difference when it gets squared? No, it's still the following. Still the original function. Here, x and y have been replaced, so we do that to this. We replace the x squared with y squared. And here is x instead of y. We can rearrange this, of course, and solve for y. We can switch the x, put it down here, put this up here. So we get this. And then we can bring the 3 to the other side and square root both sides. We'll get plus or minus the answer. Part C here is sketch each graph in B and state whether the graph represents a function. Okay, so you can have a look at this. Compared to the original, basically what it is a reflection in the x-axis. So you get that. Here's a reflection in the y-axis. Actually doesn't change, and that's why the equation is still the same. Switching the x and the y, you're getting the inverse function, and you can see what happens if it's reflected in the y equals x line. So this is a function, and this is not a function. Example 5. Given this equation, determine the inverse. So switch the x and the y's. So originally it's this. We'll switch the x and the y. We get this. And then if we want, we can solve it for y. And here we get the answer here, solved for y. You can tell what kind of line this is. This is a straight line with a slope of 1/3 crossing the y-axis at -2/3. Okay, looks like two things might have happened here. Instead of y equaling f of x equal to this, we've switched the x and the y's and then made the y negative. So let's switch the x and the y's first of all, and we get this. So instead of y equals 3x plus 2, it's x equals 3y plus 2. And now making the y's negative, we get that. We can just multiply out the brackets, we get this, and if we like, we can solve for y, bringing it to this. Another straight line, same slope of 1/3, but crosses at +2/3. Here we swap the x and the y's again. It's the inverse function, but we also do a reflection. This is going to be a reflection in the x-axis. So switching the x and y's, we get this. We now do a replacement of x for -x. Sorry, why is that? Oh yeah, because this is now x is now here. So what we've done is we've actually made, we can bring the negative over like this and make that positive. So really we've got a -x. We've made x negative. Okay, so we replace x with -x, which gives us, if we multiply both sides by -1, gives us this. Solving for y, we find we've got this. So it's going to be a negative slope of 1/3 crossing the y-axis at -2/3. And then finally, part B, the graph of y equals 3x plus 2 is given. Sketch each graph in A. So we're sketching this, this, and this. So as I've mentioned, looks like they've got both the original, this one, in all of them. That must be this graph here, and here, and here. And now this was a reflection, the y equals x line. What did we do here? We basically did two things. We did that reflection, and then we also made the y's negative, so that's a reflection in the x-axis. So this line gets reflected in the x-axis to give this line here. Finally, we did the reflection in the y equals x line again, so we did the inverse, but then we made the x's negative. So this is a reflection in the y-axis. The y. I may have said the x-axis earlier, but this is a reflection in the y-axis. So we get our inverse function and reflect in the y-axis, bringing this over to here, this over to here, and we get this line right here. It's a little bit tricky when you're doing two things. Okay, so basically when you get an equation like this, you've got to decide what's happened. So you need to figure out this, and do the replacement in the actual equation. One followed by the other. Okay, so please do all the questions for the assignment. We'll see you in the next class.